Here's another repeated measures ANOVA, but this time we're calling it a within group ANOVA. Again, there's only one group, but multiple measurements. Everybody gets measured in every measurement. That's how you can tell it's a repeated measures ANOVA instead of a between group ANOVA. So let's get the town here. Here's the data. So we're going to add a little storyline to this one. So let's pretend you get hired as a consultant to increase productivity from the employees of this giant company. So they want you to do something to come up that improves their job commitment scores, right? Everybody knows the more committed a person is to their work, the more they do, the happier they are, the more they put out. You tried something, right, as a consultant, and then you measured their February commitment scores before you did anything, I guess. And then you measured the commitment scores after 2 months. And then you measured their commitment scores after 2 more months, right? So if whatever you did to increase their commitment did work, it will show up in this repeated measures ANOVA. Okay, so let's go to town. First thing we have to do is the assumptions still apply of normality for the ANOVAs. All ANOVAs and t-tests need normality. So let's go down here and go to descriptives. Explore. We want these guys over here. And we want unclick the stem and leaf, click the histogram and the normality. So we go down to this box and they're all not normal. Got that? None of the data set is normal. So this is probably not the right test, but we're going to go ahead and run it anyway, and then I'll show you the non-parametric version of that. Right? Histograms. Yee. So you got an outlier way out here. See that guy by the number 20? That's what's causing it. We should probably get rid of that guy. But again, this is just basic stuff. And the other one, that's not normal either. Okay, so we got what we came for. It did not, the data's not normal, so we shouldn't be using this test, but we're going to run it anyway. Okay, analyze, general linear model, repeated measures. And how many do we have? We have 3. 3, 5, 10, you can have as many as you want. And I always deem this time because time has passed. And we got to define them. So there's 1. And there's 2. And there's 3. So I'm suspecting that if normality was violated, I wonder how that would affect the sphericity. It might also be violated, but again, we've got it handled. Okay, there's the 3 repeated measures. There's the means. And I see a little bit of difference between 1 and 3, but let's see if it's significant. Again, the Wilks Lambda says there is a significant difference in those job commitment scores, but let's go down to the big money box. All right, so this one, the sig value of the Mauchly's test for sphericity is less than 0.05. That means it violated. So that means we have to pick one of these greenhouse, Hunfeld, or lower level. We're going to go with the Hunfeld. And how that works is we go down to the ANOVA table. We do not pick the sphericity assume line because it violated that assumption. So we're going to go to the Hunfeld line. And you'll notice that most of these numbers are identical, especially the F scores and the p-values and the partial letter squares are all identical. The only thing that's different is the degrees of freedom. That's a hint. If you have a degrees of freedom for an ANOVA that's got decimals in it, that means something got violated. And in this case, it's the sphericity. But we're just going to look at the Hunfeld row here, and the F ratio was huge, 1037. That's crazy big. And it is significant. Good. So now we go back up to the means. And from the first measurement to the second measurement, it did increase. And from the third, it did increase. So it looks like whatever you did as a consultant did increase job commitment. Congratulations. Okay, since it violated everything, we're going to go ahead and do the non-parametric version of this. So we're going to go to legacies. And then we want, let's try that again. Non-parametric, legacy. And then we want K-related samples. I don't know if you can see that or not. K-related samples. And 1, 2, 3. Oh, yeah, this is going to be the Friedman's test. So the Friedman's test is the non-parametric version of the repeated measures ANOVA. Okay, so here they are. Right, NPAR is non-parametric, and it uses mean ranks instead of means. And I'm not going to try to explain them because I don't think I know. But this is what you do here. You basically just look at the asymptotic sig value. That's a two-tailed sig value. It's the same as the ANOVA, right? It's less than 0.001, which means there was a significant difference, and in this case, there was a significant increase in job commitment scores over the three measurements. Okay, that's it. Hope it helps. MGC.